Hey, welcome to my lair today, and this week we are going to be going over statistics and the heart of uh, quality control in today's manufacturing environment. So pretty much this week we're going to be looking at statistical process control, how we apply statistics to the dimensions and the tolerances that we are seeing on blueprints in order to help us to kind of prove that we have the right type of quality, as well as making sure that we can maybe head off some problems at the past before they become bigger problems than what they should. So I'm kind of using some past material that I've used. It's good stuff here, and hopefully it's will help you to kind of understand what's going on as we begin our study this week into statistics for industry. All right, so what are we talking about here when we're talking about statistics? Well, this whole semester so far, I've been having you measure parts and write down charts and graphs and collect your data on all the different types of measurements that we've been taking. So that collection and evaluation, or that collection of data, is important for us to use in terms of statistics. And of course, it definitely tells directly if we sit there and take one part and measure everything, we can tell right away that all of those features are correct and that they're good and that we've made a good part based on the measuring techniques that were being used. Now, in reality, in the manufacturing world, oftentimes if we've got a part lot of 1,000 pieces or 10,000, depending on what the quantities of scale are, we're not always going to sit there and individually check every single feature on every single part. It would be too time consuming. It would cost too much for us as a manufacturer to be able to do that. Typically, that is not a value added service. Our customer does not want to pay for us to sit there and do all that inspection, but they do want to make sure that we're sending them good parts. So we use statistical process control, and we are collecting data and then evaluating this data on a smaller sampling. So size, and we can kind of do a lot of inference from that smaller sampling. So as we take a look at this, statistics is all about collecting, evaluating, and interpreting of this data that we're collecting. Well, what I'm going to refer to as a data set. And then we use statistical analysis of those measurements to help us verify the quality of our design or the process that we're using. All right, so let's talk about what statistics actually are. So when we talk about statistics, we have this idea of a central tendency. Now, what is that? It is the center of distribution. So we're going to have a data set of a certain number of items, and we want to find what the center of the distribution is on the number of samples that we've actually collected. So, and that center of distribution, we've got three ways here to check that. We've got what we call a mean, a median, or mode, and you're going to need to know how to calculate each of these for this class. So now, we also refer to what's called a variation. So that's the spread of the values around the center. So we use and talk about the mean, median, or mode as the center of a distribution, and then the variation is how much that value spreads around whatever the center actually is. All right, so and then when we talk about that, we talk about a range. We talk about a standard deviation. We talk about an interquartile range as well. Now, you guys are already familiar with the range in terms of our dimensional tolerances, right? So we can have a tolerance on a length of a part, and we might say that the length of that part is 5.375 inches, plus or minus 10 thousandths. All right, now that type of range then is a 20 thousandths range on the nominal size of the 5.375 inch length that we're looking at trying to hold. So you're already familiar with some of this. Now we're just going to kind of go a little deeper in how to apply all of that. All right. Then we also refer to what we call a distribution of these patterns that we start to see. So our summary of the frequency, or how often can we expect or anticipate these numbers to show up again. So and we take a look at those. We'll develop some frequency tables, what we call histograms, and we'll talk about what a normal distribution is in terms of these frequencies that we see. So let's start out now with the mean. The mean is the sum of the values of a set of data divided by the number of values in that data set. Now, don't get confused. You are going to start to see formulas that look like this. And it's just a matter of kind of understanding what each of these symbols actually mean, and then plugging and chugging once we put that into our actual formulas here. So let's take a look at what these are. So the upside down, kind of this weird shaped U here, is what we're talking about when we call, and that is the mean value. So now this E, so the epsilon, so in the Greek letter epsilon, this, when you see that in terms of statistics, that means the sum. So here we have the sum of values. X is the data value sets, and notice it's X to the I, because right now we don't know how many I's we have. So we could say the sum of X to the 10. That would mean we have 10 actual data sets, or data values that we would put it into. If we say X to the 13, we would have 13 data values that we would be summing together. And then we take the N, and that is the number of data values. So we're going to divide that by that number of data values that we have in the data set. So let's take a look here now at what we're talking about. So here I have a data set. Let's count and see how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm given a 11 data set. So, and if I sum all these up, so I'm going to take 3 plus 7 plus 12 plus 17 plus 21 plus 21 plus 23 plus 27 plus 32 plus 36 plus 44, and we're going to end up with the sum of all those that equals 243. Now, we just counted. We know that we have 11 values in that data set. So if we plug and chug this into our formula, the mean, remember this upside down weird looking U shaped object here, equals the sum of all of our data values divided by the number of values in our data set. We get equals 243 divided by 11. And we will come out with 22.09. Now we're going to talk about the use of how many decimal places or how many values should we have. Notice up here in our data set, each of these values basically has two numbers involved, or it's kind of two places that it's hold. So down here we see that we've got a decimal with two additional places. So, and for at this point we're going to keep it that way, and we'll talk more about rounding and rounding errors here shortly as we go through that. So as a matter of fact, here it is on this. So as a general rule, we're not going to round up until the final answer. And so when we take these into consideration, so we're generally going to round to one more decimal places than are in the original data set. So in the original data set there before, we had two decimal places, so we would go to the 3. So we would go 22 point whatever that next 10 spot there in the data set is. So now we do the same thing when we get into standard deviation as far as rounding more decimal places from that as well. So let's take a look here. So let's go ahead and round this up. So we did this calculation. So here where we are seeing the mean has calculated out to 22.09, we're going to round that up and actually report our mean as 22.1. So we will round that up. Now, as we talk about the next item here, as far as measuring our central tendency, is we're going to talk about the mode. Now, again, the definition of the mode, it is the data set, or the data value that occurs most frequently. So the symbol here is what we're going to be referring to as an M. So again, we're taking our same data set now as we go. Now, as you take a look at this data set to calculate out the mode, So we can kind of see we rearranged the data set. We put it from smallest to largest here. And the mode, the number that appears the most frequently is 21. So in this case, the mode here is going to be 21, and we would say M equals 21. So that is the mode. So we have some frequency values here. We can talk about the bimodal data set where two numbers of an equal frequency stand out. We can talk about a multimodal data set where you've got more than two numbers of equal frequency stand out as well. And sometimes you might only have one. Maybe your data distribution has each one is a different number, and in that case, you probably really wouldn't have any type of a mode, so to say, to speak of, because your data set is too varied. So let's take a look here at determining the mode here of this data set. So as we look at it, so you can see we've got 63 appears twice. So as I'm looking over, so I got 48 is only once. So I got 55, 59. So I'm looking for any others that occur more frequently. So here as well, so we only have 63 that is occurring more than once, so that is our mode. So let's take a look at this one. So again, as I take a look at this, so I've got, I can start out over here with the 48. There's no other 48, so let's go to the 63. Well, I do have two 63s. What about 62? No other 62s. 59 occurs twice, so I see the 59 there and the 59 there. 58 is only once, 2 is only once. 63 we've already talked about. 5, so basically we have two modes here, 63 and 59. So, and we would say that that is bimodal. So our modes here is 63 and 59, and it is a bimodal data set. So what about this last one here? Well, we've got, again, so we've got data here is 63, 59, and 48. So this is multimodal. So we have that distribution arrangement occurring multiple times here, so it's multimodal. Now let's talk about the mean. So I'm going to actually stop the video here. We'll come back and we'll get into how we actually determine the median as well.